Alright, so welcome to my second video in the Getting Started with the Uzebox series. In this video I'll be going over how to configure and use some of the tools that will help you create your Uzebox game. So we're just going to pick right up where we left off in the last video. So open terminal, see we still have everything here. And I'm not going to lie, I don't start from scratch every time I create a Uzebox game. I usually base it off of one that I've made before. And since making the last video, I've created 2 Uzebox games, and one of those has a good make file for starting. So we're going to grab that. So git clone it's called laser. So here we go, and we'll create a new directory. Call it hello1, and we'll copy over some of the files. So there's a gameinfo.properties file, which is it holds the author name, the game name, the year. There's the license, and we'll just grab make the same directory structure as before. So we'll create the data in the default directories, copy over the gameinfo.properties, and copy over the license. So you'll see, and I like using Emacs, so we'll just install that. Alright, so we'll run that and get rid of the startup screen. So we'll call our game Hello1 and leave the other things the same. And here we go. So that's a good start. Now we're going to copy over the make file. That's in the default directory. So there we go, and let's edit it. So here we'll change this to hello1. And there's one thing in this makefile that we don't really want for this game, and that's the translucent color. That was just an advanced thing I did for that other game. So we'll save this, and we'll quit out of there. And now we'll create the actual source code file. So hello1.c. And this is just the standard stuff, that standard set of includes that I like using. So I don't usually type this every time. I usually just start from an existing game. But for the sake of example, I'm going to type it. So usebox.h is what picks up all the Uzebox header files. So now for any Uzebox game, you basically have an infinite loop because you can't really let the program terminate. And in order for it to do its thing, you call wait vsync, and the number tells you how many vsync cycles you want to wait. So this will just go into an infinite loop doing absolutely nothing. So now if we go to the default directory, we'll see we have our make file. So type make, and there we go. We have a program. The make file told it that we wanted an intro logo. So even though it looks like we're doing nothing, there's still going to be an intro. So I can run it with Uzebox. And hello1.use is the name. And there's the intro, and you see it's doing absolutely nothing. But there's our first shell of a game. In order to create a Uzebox game, you're going to want graphics. In order to create the graphics, you should understand a little bit how the graphic system works. So the Uzebox hardware has an RGB to NTSC converter chip on it. And that gets fed RGB color data from one of the AVR's 8-bit I/O ports, with 3 bits allocated to red, 3 bits for green, and 2 bits for blue. So this digital color output goes through a DAC composed of 3 R2R resistor ladders, so 256 colors are possible, though only certain colors are supported. In order to effectively design graphics for your Uzebox games, you should install a color palette that matches those R2R resistor ladders into your graphics program. So we're going to go over that now. So what this is going to allow you to do is when you create images, you can restrict the colors you use to exactly the ones that the Uzebox can display. So we'll start GIMP. And first thing I usually do is go into single window mode. Just makes it easier to use. And in order to install the color palette, click on this configure this tab button, and we'll say add tab palettes. And it's totally not intuitive, but if you right click on this list, you could say import palette, pick a palette file, click this weird button thing, and we'll browse to the Uzebox graphics directory and pick uzebox.act. So that's the color palette. And that's a good palette name, and then we'll just click import. So now the palette's installed. If you scroll up, you'll see it. If you click on it, it'll switch to it. And then it doesn't immediately get used, but if you click on this tab, now you'll see it. So these are the colors that you're allowed to use in a Uzebox game. So as long as you pick from here, it should display it. Alright, so we'll just close this for now. And usually you're going to want to line things up with an 8x8 grid. So let's start by creating an image, and you can do math inside these text boxes. So we'll say 30 times 8, 28 times 8, and there we go. And what you're going to have to do is you're going to have to say, go to the image menu, say mode indexed, and this is really important. Pick use custom palette, scroll up to the Uzebox color palette, and make sure you uncheck remove the unused colors from this color map, otherwise it won't work. So hit convert. There you go. You see how the white turned into a gray. Now you can click on the colors. You know, pick this. Fill that back in with something close to white, whatever your choice. And now you see you have colors here. So let's see, image, configure grid. So set that to 8x8. Now when you go to view, show grid, zoom in a little bit, you'll see you have a nice 8x8 grid. So that'll help you line things up. This is terrible, it's small, but so usually you'll use the pencil tool, change the size to 1, and make it a pixel brush. And now you'll be able to draw. So that's just how you want to configure GIMP in order to effectively design the graphics. Alright, so we're just going to jump right in and create something simple. we can, we'll pick a better color for this. Let's say this nice blue. And so we're going to be making, in this video we're going to be using mode 3, so that's like a tile and sprite based mode. So the first tile in your tile set defines what the clear VRAM, the clear VRAM function will clear to. So we're just going to want to set that to black. So when we call clear VRAM, it actually clears it to black instead of blue. You could draw a whole bunch of things here. There's utilities that will help you turn this graphics file into an include file for your game. One of those options is remove duplicates. So you don't have to worry that, you know, we made this giant image file. As long as you set that flag in your XML file, the duplicates will be removed. So I usually keep this top row for, you know, different colored tiles or special tiles and start the real graphics below. So you know, we could just, you know, you could do anything. Like, we'll just make a graphic, like, here, color this in. This is just a crude drawing, really crude. And you see how I'm using this grid to keep it inside the grid? That helps saving tile space and sprites. We'll learn more about that, but just try to keep it within this grid stuff. So, looks terrible. Here. You can also use the font tool if you wanted to, like, actually pick a font. Alright, so here we go. And, you know, we could, see how I went over that little bit right there? Here, we'll get rid of that piece because we don't want to go over the grid. So I'm just going to copy it, or cut it, and move it. Yeah. So when you cut, you want to make sure the background color matches your background color in the image. So we'll just cut, paste that. I'll just move it over here, making sure that it's lined up with the grid. So here, we'll save that. So we'll put that in our data directory, and we'll just call it tileset. And then the tools that come with the Uzebox expect ping files. So we'll just export that as a ping file in the same directory. You know, you can get rid of all that. So there we go. So we have a ping file. And so there we go. We have tileset.xcf and tileset.ping. Now we're going to want to create an XML file to go with it. So I don't usually type this every single time, but I'm just going to type it for the sake of example here. So this is your input file. Tileset ping, type ping, and tile width. Now these are somewhat configurable depending on the video mode that you're using, but here we're just going to fix it to 8. So once we run this through a utility, we want to create an output file, tileset.inc, and so this is the remove duplicate tilesets variable, and so this is the variable name that we'll be able to use inside the program to reference these tiles. So this is just saying we're using 8-bit pointers. Some video modes can use 16-bit pointers. Alright, so this is the basic structure. Now we're going to have to define a map. So let's see. So left is the position inside your tileset file. So that's going to be 0. Top, everything's 0 based, so it starts 1 tile down. So width, so we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And it is 1, 2 tiles high. So that should work, assuming I typed everything correctly. So now what we're going to do is we're in the data directory and we're going to run from the Uzebox bin directory gconvert, and we're going to give it the name of this XML file. And it says it worked. So it found 22 unique tiles. Now if we wanted to save some tile space, we can copy and paste this L. We'll do that right now. So we'll take this L right here, copy and paste it here, and here we'll just get rid of that line. So yeah, we'll slide this over a little bit so it doesn't look too disjoint. So now, we can also move this closer. It doesn't have to start at the first pixel. There we go. So now you see that these two L's look exactly the same. We could save it, then we can go back to export tileset.ping, and then we'll rerun gconvert. And now you see the unique tiles found before. There were 22 uniques. Now there's only 19. So just by making some things the same, you can save a lot of data in your game, because with this video mode, each tile takes up 64 bytes of flash. So we just saved a bunch of flash by doing that. So 1432, we dropped it down to 1240, which doesn't seem like a lot right now because our game is just starting. But once you start adding a lot of stuff and a lot of tiles, that really adds up. You're going to be trying to find ways to squeeze bytes anywhere you can. So stuff like that kind of helps. So I'm a big fan of iterative design, and we're not going to want to have to retype gconvert all the time, every time we change our graphic file. So let's go back to the default directory, and I like to make a file called Scratch that it's just a bash script that does stuff for me. So just quick and dirty. Go back to the default directory. So this will just do a whole bunch of stuff that we would normally be typing by hand. Now make it executable. Now we can run Scratch from this directory, and you'll see that it went into the data directory, recreated that include file, did a make clean, and did a make, and there we go. And as you add tile sets or sprite sets or stuff like that, or repetitive tasks, you can just change that Scratch file to include them, so you don't have to do a whole bunch of typing. So now let's see. Let's edit our file, and now let's, here, I'll show you. Let's open the data tileset include file that was created. So this is the output of that program. So we have a bunch of defines, we have the map, and we have the actual raw data from the tileset here. So so now we'll just include this tileset.inc, and now let's use it. So I'll go here, clear VRAM. Now this is going to clear it to black, which is not what we want, but that's okay. Set tile table tile set. So here, we'll save that. Let's just go back to our graphics program, and we'll fix that. Right. Alright, so save it. Control S saves, Control E redoes the export to a PNG file, or you can use the menu. So now let's go back and type Scratch. There. So it's really easy to make changes and to incorporate them. So here, let's see. So we'll do draw map, and you pick an X and a Y. So screen tiles H is a define that automatically gets defined for you. So we'll subtract. So there's a define map hello1 width, map hello1 height. So map hello1 width and 2 and I just want to center it. And map hello and the name of the map. So, assuming we did this correctly, it should work. So we'll run the emulator. And look at that. We have our map drawn in the center of the screen. So that's just a simple example to get you started. So before we get too involved with this example, we should probably put it under source code control. So gconfig global user.name. This just here's the, go back to the base directory, type git init. So now we're going to want to add game info properties, hello1.c, license, the make file, and our Scratch program, and inside the data, see, tile set. We could add everything. So there, we'll just do tileset.star. So that'll give us the XML, the XCF, the ping, and the include file. You don't have to add the ping because that's generated, the include file is generated, but it's nice. So if you scroll up, you'll see, okay, so we're going to be adding all this, git commit, and we'll just say, okay, we'll just accept initial commit, and there we go. Now it's under source code control. We can make changes. We could always go back to it. That just helps a lot. In case you really mess things up, you can go back, or if you want to track your history. So that's always a good idea. Alright, so thanks for watching, and stay tuned for more videos.